All right, I think we're going to go ahead and get started. So my name is Daniel. We're going to talk about ways to find more vulnerabilities in IoT devices. So anyone recognize this, this quote here? Don't have to say the name of who it is if you do recognize it, but anyone recognize the quote? Basically, we get it. You know, all these things can be hacked, and all these conferences these days always have a track on how you can hack this stuff. And of course, we're here in the village, so that is this track. The stuff is always going to be hackable. Sort of a shot at another project there. And then enough with the junk hacking, and enough with being amazed when people hack their junk. And so my main thing here is the person who wrote this is actually really smart. I mean, HD, Kaminsky smart. Really, really smart. And I just think he happens to be wrong in this case. Can anyone give an example of a space that's not horribly broken? I think most spaces are horribly broken. And I think what we end up with here is vulnerability shaming, like different statuses of vulnerabilities or security. And I don't think that's a healthy thing. I don't think it's easier or harder to hack IoT systems versus web frameworks or whatever the platform. So I think this is definitely incorrect, and we should be proud of whatever vulns we can find in IoT stuff. I want to start with talking about the naming. IoT in general is a sort of a strange name. People make fun of it a lot. So one proposed name that could be different, universal daemonization, the idea everything has a daemon that emanates from it. Universal object interaction. So everything's an object and you can interact with it in some sort of way. Programmable object interfaces, POIs. This could potentially be a better name. Transfurigated phase inversion. I made that up. I don't know what it means, but it might actually be a better name than Internet of Things. So defining IoT, I think it comes down to what definition you want to use. What are popular definitions versus what are better ones. So Wikipedia has a pretty decent one. Network of physical objects or things enabled with electronics. It makes a lot of sense. Oxford has a slightly more concise version. Everyday objects have network connectivity. That makes sense. The one I really like, and the one I usually try to use, especially with manager types and such, interface between the physical and digital world that allows one to gather information from and control everyday objects. So I think this is an intuitive one. So the question is, and this is really the heart of the talk, right? When you have a random object, a random thing that you're going to test, what do you do to it? How do you test it? What is your methodology? So it might be a white box, it might be a plane, might be a toothbrush, might be a SCADA network, ICS network, could be a sniper rifle. You guys heard about the hack that just happened? Basically, it was possible to change the target of a sniper rifle over the network, which is a big problem. The researchers said that other than this, it was pretty locked down. So that's cool. One thing that IoT is definitely not is only the security of a device. That's kind of a big misconception. We've actually talked to a lot of different manufacturers of these products and talked to them about what are you doing for IoT security, and they say, well, it's not that big of an issue. We keep pretty strong control over our source code. And they think if you don't have source code, if you don't have perfect physical access to the device itself, then you have good IoT security. And that's not the case. You've got all sorts of applications facing the IoT device or the device itself. You've got mobile apps, you've got network connectivity, you've got an admin interface, you've got cloud connectivity, and you have to test all of that. So existing approaches to sort of finding these vulns, right? You look at a collection of common vulnerabilities. So there's lists out there. We have a list. That's one approach. You can pull up your own go-to list that you've sort of made yourself, and that's one option. You can kind of think about all the things that happen bad in the news and sort of check for them, and just sort of think about, what else happened and doesn't apply to my device. So OWASP is one project that goes by the list approach, and it's made a lot of progress. It's done some good things. There are some shortcomings, though. One of them is that vulns are mixed with threats, are mixed with vulnerabilities. We have CSRF at the same level as injection. It's confusing to people. I still think it does more net good than harm, so I think it's still a good project. And we're definitely not sort of throwing stones, because we lead the OWASP IoT project and also the mobile project as well. So yeah, we know the limitations, and we think it's more good than harm. What we decided to do, though, with this project is build a high-level umbrella project, which is the IoT project, and then have underneath it separate distinctions for attack surfaces, a testing guide, top vulnerabilities, and that sort of thing. And what we're talking about today is the attack surfaces. So different approaches. So checking against the list of vulns, going to your favorite issues, and finally, what are all of the attack surfaces that could possibly exist on any type of device, right? Doesn't matter what type of device it is. Try to make it universal for, a million node massive network that is global versus whatever, a toaster. So I'm going to step through now the actual attack surfaces. So first one is ecosystem access control. So this is the idea that, going back to the idea of an IoT product being a complete ecosystem, you've got to look at everything, how the mobile app talks to the device, how it talks to the web app, how the web app talks to the internet, how the network traffic moves, everything. And you've got to look at the trust relationships between these components, right? Sometimes mobile apps are trusted to talk to the web interface and vice versa. So it's bad news. And this is the idea of overall security of that web. Next one is device memory. This one's pretty intuitive, but we're trying to isolate them very directly. Usernames, passwords, keys, all sorts of stuff can be found in device memory. Kind of typical of a thick client assessment. Physical interfaces of devices. This is something that people do naturally associate with an IoT assessment. And this is what can you plug into? How can you access the circuit board to get a root shell? How can you, press a button on the back and reset it to a default? In the security community, we've always known that once you have physical access, oftentimes you have control of the device. So this is kind of going in that direction. You definitely need to test physical ports to the box. Next, the device usually has a web interface on it, and it's usually like 1999 over again on that web interface on the device, right? So you have just the classic stuff. OWASP list, you could do whatever you want. Hit it with an automated scanner, you'll find tons of stuff. We have in our research. The device firmware. This is a really cool surface area. You can find all kinds of stuff. Very similar to like a memory dump. Hard-coded passwords, sensitive URLs, you can pull out of the firmware. Device network services. We've tested a number of devices in our research where they're actually listening open ports with root shells available and listening. So you absolutely have to test it from a network security standpoint as well. You not only can get shells, but you can get banner information, pull content out of the banners that come back, stuff like that. So the administrative interface. So we have this listed separately from the web interface that is on the device, right? It might not be that, there might be some admin functionality on that system, but there could be a whole separate interface that manages it. It could be a thick client, could be another web application, whatever it is. But think airplane or ICS system. There could be, you need to find out if you're testing an ICS system or a SCADA system, is there another module that I can download, install, whatever, that also controls this entire interface? And if it's web, then you hit it with the web attacks. Network, you hit it with network attacks. Local data storage. So there's oftentimes storage on the physical device as well. Looking there for local storage is the same as any other platform where you're looking at data, right? Is it encrypted? What kind of key management is there to pull the stuff off? That sort of thing. So cloud web interface. So not only is there a web application sitting on the device itself, there's oftentimes a whole separate cloud interface. And this is really bad because this is where the IoT comes in, right? Because now maybe there's millions of these devices, they're all out there and available. Now you've got the same list of vulnerabilities that you normally check for. In particular, in our research, we found so many that have massive flaws with weak passwords. The password's already out there on the internet for auto-config. No account lockout, no notifications of someone logging in from another location. All these sorts of problems, and it's on the internet. Some of our research, we actually looked at 10 different home security cameras. 10 out of 10 we could log into, look at the inside of the house, see when they're home, see when they're not home, watch the cameras. It was all bad news. So definitely have to check the cloud interface. Next one we specifically break out are third-party backend APIs. So much of the time when you're putting content into an application, an IoT application, maybe it's a watch, maybe it's a mobile phone, some sort of device, thermostat, whatever, you don't know where that data is going. It's actually going multiple places, and oftentimes not very securely. So definitely want to check if it's going to any third parties in addition to the regular back end. Next update mechanism, or next sort of surface area we talk about is the update system. There are so many vulnerabilities in this. Just off the top, I mean, you have the transport protocol that's used to pull down the update. We see tons of FTP, lots of default credentials for FTP credentials. The location of the update server itself actually being writable for the entire company, not just for that product. Lack of signing, so you can just modify any of the content on the server. When they download it, they download the malicious version. All sorts of things. So updates are super critical. We saw it with the BMW thing where they sort of did it the right way. Well, they did it the wrong way, and then they quickly changed it to being the right way. So absolutely critical, especially as you have more and more of these out there. Millions, then billions. If you can't update them, it's a big problem. Next is a mobile application. This one is somewhat known, that a mobile app often comes with an IoT device. Seems pretty common. And there's a whole suite of mobile application vulnerabilities that you have to look for. But you also want to look for not just the vulnerability in the app itself, but how it relates to the rest of the ecosystem. Can it control the cloud app? Can it do other things? Can it add devices into the ecosystem and out of the ecosystem? So you want to see how it affects the whole thing. Now the vendor backend APIs. So we talked about the third-party ones, but there's also the vendor ones. The question is, what's being sent there? So just because it is the vendor that's associated with the device doesn't mean you want that data going there. And oftentimes you're putting in very personal stuff, and you should assume that it is going to the vendor if you're putting it in for that product. But oftentimes it goes to 3 or 4 vendor backends, multiple third-party backends, and you want to be able to monitor and check for what data is going there. And if it's doing it securely, if it's the right protocols and such. So ecosystem communication. This is another really interesting surface area, which is different than the ecosystem access control. This is basically where the ecosystem might have heartbeats. It might have, a list of devices that are part of the system, and it's pinging them to check and see if they're alive, seeing if they're doing okay. And what is that protocol? What are they using? Is it web services? Is it SOAP? Is it REST? What is the auth on it? Is some static token that's just used for days or weeks at a time? And what all can you push, right? Can you monitor one of these? Can you replay it? Is there any replay defense? Updates, can you push updates automatically that they'll just install? So this sort of infrastructure combined with the other ecosystem look, I think gives a really good view of how it's overall secure. Next one is network traffic. This one is just absolutely critical. So there's tons of LAN traffic happening, especially when you have like an ecosystem like, well, I won't say any names, but an ecosystem where one hub controls lots of different devices. I mean, there's just lots of chatter going across the LAN all the time, some of which is encrypted, some isn't. Then you have the content going out to the internet, from the internet coming in, all sorts of different sort of vectors. You also have short range versus long range. You have full TCP/IP traffic going back and forth. You also have, do you have RFID? Is it Zigbee? Is it, other protocols like that? And this is what we kind of end up with. It's a lot. It's also not an even number, which super upsets me, but here's what's cool, right, is we're not sure about these. We really like these. We think this is valuable, but we're here so that if this is a dumb list, you guys can let us know, right? If you would like to see a couple of these combined, broken out, added, subtracted, we forgot 17 of them, whatever, just let us know. This is the project that houses all this stuff. It is an official OWASP project, OWASP IoT Attack Surfaces project, and it sits under the OWASP IoT Security Project. And that's the URL. So one of the cool things you can kind of do if you think from like a consulting or as a manufacturer, what can you do with this? You could do this kind of mapping. This isn't explicitly part of the project, but this is the type of thing you can do with it, right? You can go from a surface area and say, in a surface area, you can possibly do this vulnerability and get this type of data, right? And it's just a very clear way to see what your problems are and how to go about fixing them. So going back to the network real quick, really want to sort of talk about this. This is something I find really interesting as a surface area is being able to look at what's going across and if it has any special data in it. So this is kind of what most manufacturers and probably most customers think they have when they get something from Best Buy. They're like, well, yeah, there's one secure connection. It goes to one server. Everything's fine. This is kind of what they actually have. Clear text sensitive data, it's going to 15 different locations. They're not even sure how they're related or what those relationships are. And it's all bad news. So what I like to look for in pcaps are how many connections were made while running this IoT application. Let's say it's a smartwatch or whatever, a mobile app. And you put in whatever, a fake social. You put in a fake social, you put in a date of birth, you put in whatever, how many heartbeats per minute you average, whatever sensitive data you put in. And the question is, where did that get sprinkled around the entire internet? How many destinations? Was that data in any of those connections? Did it go to third parties or only the legit backends? And if you see any of this data in pure network traffic, why is that bad? Because it wasn't HTTPS, right? So that could be a problem. So what I've done is put together a tool that will do this for you automatically. So this tool will take a pcap, it will parse it, it will break it into its different pieces for each destination that it's being communicated with, and then it will search for sensitive data inside of each of those individual pcaps. So it could tell you which connection actually caused it. So it's actually really easy to do this. There are multiple ways. You could do it with like virtual switching, like on ESXi or Hyper-V. But you could just go get this device, first of all. $180 on Amazon. You could actually just tap where you have a choke point that goes to the internet. Get your pcap. And let me just show you real quick what this looks like. All right, so, I mean, this is basically what it's doing. We're running T-Shark. We're running TCP dump. Also of note, we're actually getting a list of bad strings, basically bad honey tokens that are being searched inside of the PCAP. This is from our SecList project. Actually, myself and Jason Haddix presented on this at Black Hat Arsenal on Wednesday. Cool project, check out SecList. We're pulling a pattern matching list, in this case, for pcaps strings, and we're searching through them and giving output. And I'm at DEF CON, so I made a video because we're not getting on here. So that's the code again the sec list. T-Shark, the TCP dump piece. Again, that's breaking it into an individual host list and then building an individual pcap for each host. And now we're going to run it. So first thing it does is go and retrieve the sensitive strings. And then it starts searching for those strings. Ignore that top one. Like to go back to a job on Monday. So it's looking for AES keys, secret keys, scanning the PCAP again, 64 connections to 41 hosts, shows the actual host names that we're connected to, and shows you the hits. And this is actively being developed, put it together a few days ago. So it'll probably be a lot better by the time you get back to work. But already breaks out the hosts, tells you if there are any hits, and these are automatically critical or high findings, especially if it's going to an untrusted host, which I'm about to add a bunch of reputation stuff into it. So definitely worth checking out. So I also want to mention a couple of sister projects. One is I Am the Cavalry, which is run by Josh Corman and a few other guys. And it's really cool. It's focused on public safety in IoT. So car security, airplane security. They have a 5-star system that they're developing, definitely worth looking at. There's also the Build It Securely project run by Mark Stanislav and Zach Lanier. And this combined with our efforts in OWASP kind of give you a rounded out sort of approach there. This is a Craig Smith slide. Craig Smith is sitting right here. And he's done a tremendous amount of research and work on this project. So tons of research on the HP side, on the OWASP side, maintaining the project, reaching out to people, just massive props to Craig. All right, takeaways and goodies. So IoT testing is the same as other testing. And we shouldn't have Vuln shaming around IoT not being some sort of elite thing. IoT security is not device security. It's absolutely critical to understand, especially for manufacturers who unfortunately are the people who get it the least, in my experience. The Attack Surface project is basically proposing a universal way to attack IoT. Any product, any product type, erasers, jet planes, whatever. A big part of that is the network piece. Caparser is a tool that can do that analysis for you. It's free. It was released today, and it'll be improved, ongoing. Craig Smith is awesome. I think we established this. And there's a handout. So we actually have a handout, which is, it's not the exact list that is up there, but it actually has a whole bunch of different ways to look at any IoT device, and I think there will be enough. That's what it looks like, and here's the meta. Happy to take any questions, and I appreciate the time. Yep. Yeah. Yeah, it was discussed a bit last night, but it's a great point. What's really cool about the Umbrella project is that if someone has an idea like that, any sort of idea, we're already working on a pure testing guide, similar to the OWASP testing guide, but for IoT. But any sort of project like that that is under the umbrella but not quite the same, we'd love to have it, and we'd love to have you lead it. So you just signed up. I mean, I hope you have an OWASP. Hope you have an OWASP email address. They're free. Yeah, definitely these types of projects really, really good to group under it. And it keeps us from having to use the top 10 name, which is troublesome. The top 10 name has done a lot for people, but it also sort of confuses people, and that's why we're trying to avoid that. So if you have a project idea, definitely come and contribute, and reach out to us, and we'd love to hear from you. Other questions? Which one? Oh, the device. Yeah, I always confuse dual-com and Qualcomm, but yeah. Yeah, this is the device. You basically have an in and you have an out, and you have the where all that traffic is going, right? And actually, if you just Google the device, it's got a full doc on how to configure the various ports for where you get the packets. Yeah, and it's up to gigabit, so. Any other questions? All right, so Jason Haddix is right here in the front row. He is speaking at 4. Just erase all other things that are at 4 o'clock and go to his talk. You should definitely go see it.
Where is it?
It is in the 101 track, DEF CON. It's right next door. Yeah, it's a collection of like tons and tons of methodology stuff. You should definitely go. I'll be there. All right, thanks a lot.